Hello, and it's your boy, and we're back at it again with another maths video. Today we are going to be continuing the idea of the notation used in differentiation. So in my previous video, just a quick recap, we said that, for example, we have a function, let's say p is equal to 4a squared plus 2a, and I want to find the gradient. The first thing I'm going to do is to come up with the derivative, and in this case, the derivative notation-wise would be in the form of dp dA, and that would be equal to 8a plus 2. So let's say I want to find the gradient of this function when a is equal to 2. I would simply then come to my derivative, plug in my a as 2, 16 plus 2, that gives me 18, so the gradient would be 18. So the important thing that I want you to focus on is the notation. Now, from your previous study of functions, which I did make a playlist of, by the way, check out the playlist on functions and look at the function notation that I did there. Sometimes we express functions as, for example, f of x, g of x, and so on and so on and so forth. So this is how we normally express functions. So what about if we have a function here, the same function, but let's make it x this time, 4x squared plus 2x, okay? And instead of saying y is equal to 4x squared plus 2x or p is equal to 4x squared plus 2x, we're going to say f of x is equal to 4x squared plus 2x, okay? So in this case, how would we denote the derivative? We want to find the gradient somewhere, and the first thing we want to do is we want to find the derivative. Well, how would we actually denote the derivative? What would be the notation? Well, we're not going to do this dp, dA thing, dy, dx, whatever, because it only works if our function is expressed strictly like this. But the second we start introducing this function notation here, f of x, g of x, h of x, or whatever it is, then we have a different kind of notation. What we're simply going to do here is the derivative is going to be denoted as f prime of x. That's how we actually read it, f prime of x, and 8x plus 2. So the important thing is this part here. So we're simply going to take an apostrophe and we're going to put it in between the f and the bracket x. This is actually how we would denote it. If our function was g of x is equal to 4x cubed, and we want to find the derivative of this function, then the way we would denote it is we would say g prime of x. Okay, that is badly written. Let me do that again over here. G prime of x, exactly. G prime of x, and that would be 12x squared. Okay, that would be the derivative in this case. Remember, I haven't yet started showing you how to actually get the derivative. The only thing I'm stressing at this point is the notation that we actually use. So we would use g prime of x. So g prime of x, f prime of x, this is the second notation that we can use to denote derivatives. Let's say we have h of x is equal to 10x to the power 2. And let's say we want to find the derivative of this function. How would we denote that? Well, quite simply, it would be h prime of x is equal to 100x. So this is how we would denote the derivative. This is how we would denote the gradient function. So all these things here, these are the derivatives. So this is the notation that we actually use. So anyway, that brings me to the end of this video on showing you the notation that we use in calculus whenever we're differentiating. In the next video, we're finally going to be starting to differentiate, and I will show you how you actually differentiate. As usual, guys, if you enjoyed the video, hit the subscribe button, hit the notification bell, like the video, leave a comment below, share the channel, and until next time.